Assalamualaikum and very good morning to Puan Norha. So today I'm going to present about the experiment 5 that was conducted in the simulation. So what is basically a 7-segment display? So 7-segment display is actually a form of electronic display device for displaying decimal numerals that is an alternative to the more complex dot matrix display. So 7-segment display are widely used in digital clocks, electronic meters, and basic calculators, and also other electronic device that display numerical information. So without wasting any time, let's proceed to the first part, which is the objective. So the objective is to convert binary coded decimal to numerical display. So basically, it is about converting binary coded decimal to numerical display. So then let's see about the equipment and component that we're going to use. So this is the component that we're going to that we use in this simulation. So the first one is the IC 7447 common anode 7-segment display, 7 LEDs, breadboard, 5-volt battery, 750 ohms resistor, and 7 330 ohm resistor, 7 switches, and also wires. So for the procedure, there are several procedures that we need to follow in order to successfully achieve the experiment. So the first one is the anode of the 7-segment display is connected to a battery, and the input pins of the 7-segment display must be connected to 150 ohms resistors, and the LEDs were connected to each of the output, which is the lowercase of a to until G. The LT, BI, and RBI was set up appropriately. The input A, B, C, and D played to activate the LEDs, and the truth table is constructed based on that. The next one is the LED is replaced with a 7-segment display input. The input A, B, C, D is control the display, and the truth table is constructed in order to explain the effect of input 74478 TTL to the 7-segment display. So let's move to the data, the experiment data that we got based on the simulation. So there are 3 actually when we run the simulation. So the first one is the 7-segment display of decimal 1. Number 2 is 7-segment display of decimal 0. And number 3 is the 7-segment display of decimal 9. So the next one, these are the truth table that was constructed and also the data that was collected is recorded here. The first one is the truth table for built-in LED, and the second one is the truth table for 7-segment display. So the discussion based on data collected were based on the simulation that was conducted on the LiveWire application. The function of this experiment is held to comprehend the TTL function as decoder that is attached to a built-in LED as well as a 7-segment LED. Firstly, the decimal 1, 0, and 9 are manually displayed. So in order to execute the decimal 1, 0, and 9, the first one is the decimal 1. The switch B and C are closed. For the decimal 0, all switches are closed except the switch G, while for the decimal 9 to display, switch G is needed to be open. Moreover, a truth table of the relation between input the uppercase A, B, C, and D, and the output of lowercase a until G LEDs is constructed. The LED will light up, which means the output is high, and if the LED did not light up, means the output is low, as the combination of switches is set up. So actually, each of these LEDs represents a segment of a numerical digit that will be displayed. The LED observation are dependent on the combination of the truth table. For instance, inputs 0000 showing all LED light up except switch G as its outcome, while all LED are light up for input 1000. Meanwhile, for the 7-segment display, which consists of 7 LED that are arranged in rectangular pattern, all switches were tested accordingly. So based on the data, all decimal numbers within a total 9 segments were clearly displayed in the simulation. The display number that are clearly showed are 1, 2, 3 until 9, as we can see from the table just now. So for example, for the input 0101, shown switches B and E low while others high to display decimal 5. Other than that, decimal 8 is displayed when the output all high. Lastly, there are some errors, source of errors actually, that we can obtain and identify from the simulation. So firstly, it may cause from systematic error or random error that can lead to a different reading of data. So next is the connection should be verified before running the simulation. So for example, we should double check open and close switches before taking the data in order to get an accurate and precise result. So for the conclusion, in conclusion, we can see that converting binary coded decimal to the numerical numerical display is determined. As a result, we can conclude that the experiment was successful, since they follow the theory of the circuits for the 7-segment display from the results in the truth table of the 3 circuit of the 7 display. I think this experiment is a very successful experiment based on the simulation that was conducted. So I think that's all from me. Thank you and assalamualaikum.